The LightStanza Revit plugin enables you to export a full or partial Revit model for analysis in our cloud-based lighting simulation software. So we're going to look at how to install the plugin, how to get your Revit file set up for export, and how to do a lighting calculation using a Revit model. And so to begin, you'll first want to make sure that you don't have a previous version of the plugin installed, and so you can search for it in your Programs and Features list, the Installed Apps list. And if there's an older version, you'll want to be able to uninstall that before going further. And so we'll do uninstall. And then we'll get a window indicating that it's removing the program, just kind of preliminary setup. And now with the old version of the plugin uninstalled, we have room for the new one. And so to find the plugin, you'll go to lightstanza.com and then find plugins and families under the resources tab. On this page, you'll also find some other useful information and a library of Revit families. But for the plugin, we'll just use this direct download button to get the latest version of the app. And now with the plugin downloaded, we can start the installer just as you would install any other desktop program. The LightStanza Revit plugin currently supports the 2021 through 2026 versions of Revit. By default, it'll install it for all the major versions, or you can select certain ones if you don't want it for each version of Revit. And then we'll click Next, and then Install to proceed with the installation. And finish. And with the plugin installed, we'll now be able to use it to export any Revit model that we have open. So with the plugin, you get this LightStanza tab, and then there's some configuration you'll want to do before proceeding with the export. So LightStanza comes with a set of built-in parameters, which you can access using this Load LS Parameters button. So when we click that, the plugin will attach certain parameters to all the lighting fixtures in the project. And so now with the parameters loaded, if we select one of these linears, for example, we have some options here. So LS active is essentially an on-off switch, just dictating which fixtures actually get exported to LightStanza. There's the opportunity to set fixtures to be emergency fixtures, so they'll play in emergency mode calculations. This would be like if they were connected to an emergency backup circuit or a battery, something like that. And then you can also set an output factor. If you need to derate the output in emergency mode, it's 100% by default, but you can reduce that if you like. And then we have this LS luminous length parameter, which will factor into linear proration. And so with these linears, I actually have the same photometric file assigned for each of the different lengths. And then LightStanza will take the original IES file and prorate it based on the total length of the fixture. And so it's reading this LS luminous length parameter. And then if you already have families that were set up using a different parameter, say you named it custom length or something besides LS luminous length to control the length, you can easily add that to the LS luminous length parameter using this copy to LS luminous length button. And so in this drop down list, it'll actually go through and read all the length parameters associated with any fixture in the file, and then you can copy them as needed. You don't even have to use the same parameter. You can go through this whole list and it'll copy and update and apply the last one that it finds. And then one final thing to set up, there's this Set LS IES Basis Length button. That will go into the photometric file that's attached to the type properties. And so just to kind of show that, if we open Edit Type, I have this 4-foot IES file assigned to the photometric web file parameter. And then Set IES Basis Length will go through and actually read that length from the IES file and fill in this LS IES Basis Length parameter automatically. And so then that will be used as the basis to calculate the proration. And so for this example, I actually have a 28-foot version of this, and so it'll just take the ratio and give me a proration factor of 7 to scale the output. Scaling the output's optional. You can also just use custom IES files for each length if you prefer, but that can be a big time saver. And so that's the basic setup for a Revit export. From here we can actually go into the export wizard. One thing I want to do first though is actually reduce the complexity of the model. And so you can export from any 3D view. You can also export space by space or level by level if you prefer. But what's helpful about using a 3D view is you can enable the section box using this checkbox, and then reduce the model to an area of interest. Let's say we don't actually want to consider the parking lot in this example, we're just looking at interiors. We can bring the section box in to get rid of the landscaping and just make the model a little more simple to work with in case we don't need to view the whole thing. You can do the whole thing as well. There's not really a limit to the size, it just depends on what you're interested in looking at. And so if we do export, now we'll get this export to LightStanza option. And then here it's a simple wizard that kind of walks us through some different settings. And so we'll actually want to set the default folder path for this. And so this just kind of controls where it gets uploaded to. And so I'll put it in my demo videos folder. You can use any folder in your folder structure. Just be aware that that's where it's going to land when it gets to LightStanza. And then under extents, we have a couple of other options. So right now, because we're exporting from a 3D view, we'll want to use this section box approach. You can also select the floors from your model, and so here we get a list of all the rooms and floors, and we could export those individually. But since we set up the section box, we'll want to use that option here. Level of geometry detail just controls how complex the model actually comes in. So, think LOD4 is kind of middle of the road. It'll start reducing the detail you see in cylinders. It'll start appearing more like hexagons if you go lower in level of geometry detail. But typically that'll be okay. We're only interested in the lighting simulation results, and then you may want to crank this up if you're interested in high quality renderings, but we'll leave that at 4 for now. And then with the 3D view, like I mentioned, you can export from any 3D view in the model. We typically recommend adding a dedicated view called LightStanza Sync View to sync changes back and forth between the two programs. But for the initial export, you can use any 3D view in the model. It doesn't need to have a certain name, and so we can stick with this 3D view. And then LightStanza also comes with a set of view templates. Or you can select one of your own if you want to customize which categories get exported. And so the defaults we have, there's LightStanza default export. That'll include a little more detail, things like furniture. And then the LightStanza minimal export will be kind of the bare bones to actually do the lighting analysis. So floors, walls, ceilings, windows, luminaires, and not much else. So just be aware of which template you're using before you export to make sure you're getting all the categories that you need. Then kind of stepping through the wizard from here, on other settings, we have the opportunity to create calculation grids automatically based on the room and space definitions. And so it found 37 rooms in this file, and it'll create a grid individually for each of those. And we can set the work plane height globally. And so we can do a 2.5 foot work plane height or 30 inches, which is pretty standard. Or for emergency calculations, you may want to look at putting the calculation points on the floor instead for like an egress path or something along those lines. But for this, we'll just stick with the default of 30 inches. And we can bring in all the levels from the Revit model. The only one we're really going to look at in this example is the first floor plan, but I'll leave the rest enabled just to kind of show what that looks like. There's no problem with exporting extra levels. They can just kind of make it more complicated to navigate. If you have hundreds, say, in a Revit file, you may want to look at turning these off. But from here we can do next one more time. We have a few more options about whether to include lighting fixtures or not. If you don't want to use the lighting fixtures from Revit, you can also add them after you've exported in LightStanza, but since we set up the parameters, we can go ahead and include those. And then finally, we get this warnings tab, which just sort of scans what's about to be exported and make sure they're within reasonable tolerances. These thresholds are guidelines, they're not hard limits. You can actually still export if you're exceeding one of these, but it's good to review this just to make sure you're getting kind of a reasonable model exported. And then from here we'll use export, and then it'll start processing the geometry data from Revit and open this model in our web browser for our lighting simulation. And now with the export complete, we've essentially created a digital twin of our Revit model in the LightStanza web-based environment. And so by default, you'll come into a 2D plan view, and then there's some navigation options towards the top. And so under this drop down, we'll see all the levels that we exported, all the ones that we had checked in the export dialog. We'll be working on the first floor plan, but you can also navigate to other elevations in the model. And so if we want to look at the roof, you can switch to that from here. Probably not the most useful for this design, but it can be helpful for multi-story buildings. If you need to get to different areas quickly, this is a fast way to do it. We can also just review the geometry we got by toggling to a 3D view, and so that's this cube button here, or the hotkey T. And so this kind of shows the perspective of the building in 3D, just to kind of validate that everything came in the way we thought it should, and I think that's looking pretty good. And so we can switch back to a lighting plan view. The other thing that's kind of nice to check when you complete a Revit export is the luminaire information. And so we have this lighting panel opened using this A lamp icon on the far left. And then these are the fixtures that we were able to extract from the Revit file. And so we have our down lights. If you kind of hover over those, they'll highlight in the model so you can see where they are. And then for our linears, one other thing to note is we had a proration factor applied. And so you see this little P underneath the instance manager. That's indicating that the output of this linear 4-foot photometric file was scaled based on the length. And so we can review that here as well. We got a few different proration factors, 5 for the shorter ones, and then all the way up to 7 for the longer ones. And so this will get applied to the calculations. And then we also got a calculation grid for each and every room that was in the export. And so we can review the names of those if we go to the calculation grids panel on the left and then expand our first floor points. It added calculation grids using the room names from Revit. And so this came in automatically. They don't need to be drawn manually as long as you already have the rooms set up in Revit. And then one final thing to review before we start a simulation is the material properties. And so there are two ways to bring in materials from Revit. By default, we recommend not really trusting the Revit materials, and we just apply these IES default materials at 20% for floors, 50 for walls, 80 for ceilings. And then there's the ability to override those if you like. And so just to kind of show that, we can actually go into a 3D view. And so if I select one of my calculation grids, I can view location in 3D. And then override the material as needed. If you want like an accent wall or something like that, you don't need to use the defaults. That's just kind of the safest option if you're not sure exactly what the reflectances are. But we can change this to something more reasonable. I'll apply this blue material to this just to kind of give an example. And then this is also settable in the settings. And so if I open up my user settings by clicking the user icon and settings, under models, we have this automatic default reflectance values for Revit models. And so because I had that enabled, that's why I got those 80, 50, 20 defaults. If you uncheck this before the export, then it'll actually use the true materials that are in the Revit file. And so if you spent time making sure those reflectances are already accurate, that can save you a lot of time rather than having to override the materials on an individual surface basis after the export. So now we're all set up to run our lighting simulation. I'll switch back to a plan view just to get it started. And so we can calculate the entire building. So if I click grid analysis, it'll just do the whole floor. There's also the ability to calculate individual spaces. And so I could kick that off just by right clicking and calculate an individual space. That'll perform faster, and then you just have to kind of repeat the process to get every space. But so just some different ways to get into the calculation. And then if we go back to our 3D view, I can right click and do view location in 3D once again. And then from this perspective, we can also kick off a rendering to actually see this in a more photorealistic way. So now with our rendering complete, we can actually pull that up visually just to kind of see what it looked like. So now we've actually pulled in all the geometry from Revit. You can see some of these materials were already applied to the cabinetry. And so this is a kind of a more realistic visualization than what you see in the viewer. And then you can also save this image if you like, but just something that's a little more accurate than the rendering technology that's built into Revit. This will give you a more photometrically accurate rendering than what you could do on the Revit side. And with our grid analysis also complete, we can return to our lighting plan view just by using the button on the activity card. And this will show me my point-by-point results for all the rooms in the building, and then also give a heat map visualization. Many of these rooms didn't have any lighting fixtures, so that's why we're getting a lot of zeros, but for the ones that did, it completed the simulation and will give us point-by-point results. You can view them in a more detailed way under the reports option. And so in here, there's also the ability to sync this back to Revit. And so now that we have our grid analysis complete, you can use this send calc points to current Revit view option. And then there's also the ability to send schedules back to Revit as well. If you want to save this information in your Revit file rather than viewing it in LightStanza, there's the ability to do that. And then for sending the calculation results back to Revit, it'll look at which view is active in the Revit model, the current Revit view. And so back on the Revit side, you'll want to make sure you have a 2D view open rather than 3D. And so we'll send the point-by-point results back to our ceiling plan so we can see them in context where the luminaires are. And then in our LightStanza report, we can click Send Calc Points to Current Revit View. And then it'll think about it for a minute, and then it'll start loading these into the Revit model. And once that's complete, these will be saved as sort of a CAD background. It's actually a DWG file that's being saved to the ceiling plan. And so we'll be able to view those in our Revit model. This step is optional. If you don't want to send anything back to Revit, you can work entirely in LightStanza, but this can be a good way to archive and access your results. And so now I have the point-by-points back in Revit, and I can view them just sort of to compare them to what I saw on the heat map. This is sort of a lower resolution kind of view, but it can be useful just to review the point-by-point results. And so just like that, we've completed our point-by-point lighting calculations for this entire first floor of our Revit model. Thank you.